So problem number one, they're selecting 3 households. They've got either 2, 6, or 7 people in them, and they're taking a sample of 2 people. And so with replacement means you can pick that same number twice, and that's how they get this 2 and 2. So here's what they've got, the different possible ways of picking 2 of those numbers with replacement. Notice there are 9 total possibilities. That number 9 will come into play here in a bit, okay? It says part A, find the variance of each of the 9 samples, then summarize the sampling distribution of the variances in the format of a table representing the probability distribution of distinct variance values. Okay, probability distribution, we're just trying to make a table, but the trick is you got to find that variance. So variance for a sample, S squared, you take your number that you're looking at minus the mean of the sample and square that and divide by n, which is, wait, I think it's n minus 1. N minus 1, okay? Let me make a note of that. And that's gonna how you're gonna do this for each of those sample values. And so what was confusing for me was that the first value is actually 2 values. It's 2 and 2. So I don't have enough room here on this paper, so I'm just going to try really hard to squeeze it in. You look at your first value right there, 2 and 2, and you have to find the mean of that. Well, the mean is just the average. You average those numbers, 2 plus 2 divided by 2. The average is obviously 2 there, okay? So we want to use that formula up above. This is the formula for variance of a sample. And it's kind of tricky. It's not the easiest thing to do in the world here for variance. We want to take our first x number. The trick is there's 2 different x numbers. So we have to do this twice. So we take our first x number 2 and we subtract the mean, which is 2, and squared. Okay. Plus we're going to do the second x number 2 minus the mean again is 2 and squared. And then we're going to divide by n minus 1. Now remember that n number was this 2 right here. So 2 minus 1. Now, it shouldn't take you too long to figure out that that's going to equal 0. 2 minus 2 is 0. You square it. And 0 plus 0 is 0. You get 0 over 1, which is 0. So this value right here is 0. All right, that variance for that first data point there, 2, 2, is 0. So we have to do that for each of those things now. Okay, so the next one I do is 2 and a 6. Now the average, or the mean of those 2, add them and divide by 2, that's 8 over 2 is 4. The average, the mean, is 4. So we do the first number minus the mean squared, and then the second number was 6 minus the mean and squared over 2 minus 1. You're going to have a negative 2 squared, which is 4. You're going to have a positive 2 squared, which is 4. 4 plus 4 is 8. 8 over 1 gives me 8. That's my next number. Okay? We have to do that again and again and again. We have to do that up to 9 times. We have to do that for each of those data points. All right, so then you got this one, 2, 7. So the next one is 2, 7. Find the mean. 7 plus 2 is 9, divided by 2 is 4.5. Here, your mean is 4.5. So this variance formula, we're going to take our x number. Eight's not an option. Okay, here's the thing that you have to do. Is it's going to make you put them in numerical order. So check one, like your third box is so I bet that's going to be your third number. 8 is an option, it's just not the second option. So then I take my first x number minus the mean squared, and then this one minus the mean and squared over 2 minus 1, blah, blah, blah. That's going to give me 12.5. Okay, that is that variance of that sample value. So we do this. I'm not going to go through and do the calculations all 9 times, but we're going to do that, and we're going to get the numbers. We're going to get another 8. We're going to get another 0. We're going to get a 0.5 and a 12.5 and a 0.5 and a 0. So 1, 2, 3, 4, 5, 6, 7, 8, 9. We're going to get 9 values there, and you're going to notice that some of them match up. And so these are the variance values for each of those sample points, right? And so what they want you to do is kind of put them in order in this table. So I've got a 0 and a 0.5 and an 8 and a 12.5. I've got 4 different values. And then their probabilities, since there are 3 of the zeros, that probability would be 3/9. Not sure if you have to reduce that to 1/3 or not. 0.5, it looks like there are 2 values, so that's 2/9. 8, there are 2 of them, so that's 2/9. And 12.5, are there 2 of them as well? 2 of them. Okay. Keep in mind that your probabilities have to add up to 1, which they do. There we go. That's the first part of this question. I think that's really hard because you probably didn't remember that formula. And then the fact that there were 2 numbers you had to add together makes that formula even more complicated. But there you go. That's that first part. Part B says compare the population variance to the mean of the sample variances. And I think this right here kind of gets to the main idea of the lesson. We're comparing the overall population variance with the mean of the sample variances. So let's do the mean of the sample variances first. Okay, we know how to find the mean. You add them up and divide by the number of numbers. So your numbers were 0, 8, 12.5, 8, 0, 0.5, 12.5, 0.5, and 0. There are 9 of them. So we're going to add those up and divide by 9. And just trust me on this, I get approximately 4.667. Okay, that is the mean of the sample variances. Okay. Now we want to calculate the population variance. Am I going too fast? So the population variance is easier to calculate. You don't have to do it 9 times. You just have to look at your numbers. So the population variance, you've got to go back and look at your original, your original numbers are 2, 6, and 7, right? So 2, 6, and 7, we're looking at those numbers. And we just have to do that same formula on those 3 numbers, essentially. Okay. So remember what the formula was. The formula was, well, I guess for population, it's slightly different. For population variance, it's a sigma squared. And it's the sum of x minus mu squared over capital N. And essentially that's the same formula. Your mu is the mean. It's just the population mean. And capital N, I guess, is different because capital N is the number of numbers. There are 3 of them, 2, 6, and 7. All right, we don't have to do n minus 1 this time. That was for the sample. It's a different formula for the sample. For population, it's the number of numbers. That's 3. So this will be a little bit easier to calculate, but we want to find the mean. So mean, we're going to add those 3 numbers, 2 plus 6 plus 7, and divide by 3. We've got 15 divided by 3 is 5. So the mean is 5. we're going to have to use this formula for population variance. So sigma means sum. I'm going to use this formula. Now remember, the first x number, the first x value is 2. So we're going to go 2 minus the mean squared over capital N, number of numbers, 3. We're doing a sigma, so we're doing a sum. So I'm going to add together the next value. The next value was 6. So 6 minus the mean is 5 squared over 3 plus the third value, x, the third x is 7 minus 5 squared over 3. 2 minus 5, that's negative 3. Squared is 9. So you've got 9 over 3. 6 minus 5 is 1. Squared is 1. So that's 1/3. So that's not equal, so it's plus. 1/3. And 2 squared is 4. You've got 4/3. Add those together. That's 14/3. 14/3 is approximately 4.667. And so you're supposed to notice that our two values that we found are equal. The mean of the sample variances was 4.667. And then we found the population variance, and it was also 4.667. That's kind of your basic idea. And so where are we at here? The population variance is equal to the square root of the mean. Nope. Population variance is equal to the mean of the sample variance. Yeah, that's it. That's the one. Population variance is equal to the square. Okay. Do the sample variances target the value of the population variance? Basically, that's the same question. It's saying, are they the same? Yes, they are the same. Okay. And if they're the same, then we're going to say it's a good estimator. All right. So the sample variance targets the population variance. Therefore, the sample variances do not. Okay, let's not make a good estimator. Sample variance do not target. Nope. Sample variance do not target. Nope. Sample variance target the population variance. Okay. Therefore, sample variances make good estimators of population variance. That's what you're supposed to notice. And then I don't know what this is down at the bottom. It's just like the answers from before. We had a 0, we had a 0.5, we had an 8, and we had a 12.5. I don't even know if you see that on your Math Excel when you do that. I'm not sure why that's even there. So that's problem number 1. Problem number 2 is kind of the same thing, except it's way, way easier. If you look at it, it looks like the exact same question. The main difference, though, is it's asking about median instead of variance. And so what's going to make this much easier to do is it's much easier to calculate the median than it is the variance. Variance, we had that formula, we had that other formula, okay, and you had to calculate the variance. Here we're just finding the medians, okay? So think about the medians of well, the sample, okay? So sample medians. And we can do that in our head. Remember, median means middle. So what's in the middle of 2 and 2? What's in the middle of 2 and 4? What's in the middle of 2 and 12? If you can't do that in your head, it's just like finding the average. When you only have two numbers, you just find the average. So 2 plus 12 is 14, divided by 2 is 7, okay? Now technically, I'm not finding the average, but when there's only two numbers, the median and the mean are the same, all right? So what's in the middle? What's in the middle? What's in the middle? Again, that one's hard to do in your head and just see it. So add them and divide by 2. That's 16 over 2 is 8. That's going to be 14 over 2 is 7. And you can check it out and just see if 7 is actually in the middle. If you don't believe me, that's going to be 8. That's going to be 12. Okay. Those are the sample medians. And so you'll notice there should be, I guess, 6 different things here. If you put them in order, there's a 2, there's a 3, there's a 4, There's a 7, there's an 8, and there's a 12. I see those different numbers for my medians. And so then the probability, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9. I only see one of these, so that's 1/9. And I see a couple of 3s. I only see a 1, 4. I see a couple of 7s. Oops, that's supposed to be a 9. I see a couple of 8s. And I see 1, 12. I would just kind of double check and make sure that adds up to 9/9. 3, 4, 5, 6, 7, 8, 9. That looks good. All right, so there's my distribution, right, of these sample medians. Part B says compare the population median to the mean of the sample median. So again, I feel like this is kind of the main idea right here. We want to talk about the population median compared to the mean of the sample medians. Okay, so we want to look at the mean of the sample medians. And you know, if you know what you're doing, this isn't that bad. We're just finding the mean of these numbers. So 12, 2, 3, 7, 3, 4, 8, 7, 8, 12. Add them up, divide by 9. I believe you get 6. The mean of the sample medians is 6. So this right here, the mean of the sample medians was 6. Now the population median is even easier, because all you have to do is look at the population, and the population were these 3 numbers. So the population median, 2 and 4 and 12. Remember how we find the median? It's not the same thing as the average. We don't have to do any work here. We just need to find the middle number, and that's 4. That's the median. That's the population median. We've got this population median of 4 and a sample median of 6, and you're supposed to notice that they're not equal. Those two things are not equal. Population median is double. Nope. Population median is equal. Yeah, I think that's it. Oh wait, no, it's not equal. Duh. Not equal. Population median is not equal to the mean of the sample medians. It is also not half or double. That's it. That's the one. Population median is equal to half the mean. No. Okay. C. So then we've got, do the sample medians target the value of the population median? That's just asking you if they're the same thing. And they're not. And part B just told us they're not equal. They're not the same thing. And so therefore it doesn't make a good estimator. So which one is that? Sample medians do not target the population median. So sample medians do not make good estimators. It's choice D. Okay. I think, I mean, I don't know. I think it's tough to understand what to do there, but now you got it. Okay. Number 3. Okay. This time it's the same deal, except we're going for range. So it's exactly the same thing, except we're talking about range. We want to do these things 2 at a time with replacement. It's going to end up giving you 9 examples. It's kind of the same thing. So if you think about range, So when we're talking about sample, range is just big number minus small number, how far apart they are. This range is 0. This range is 10. This range is 4, 10. All I'm doing is subtracting the numbers. Big number minus small number. This is 0. This is 14, 4, 14, and 0. So I'm really doing the same thing every time. That variance question was by far the hardest one, though. So my sample ranges I see could be 0, 4, 10, or 14. Probability, I've got 3 of these, 2 of these, 2 of these, and must be 2 of these. There's my distribution. So then compare the population range to the mean of the sample ranges. So we want to find that mean of the sample. So we add those numbers up. I feel like I shouldn't need to write all this out, but I want to be clear. Add them all, divide by 9, and I get about 6.22. About 6.22. And then, so the mean of the sample ranges was 6.22. The population range, okay, population is always going to be easier to calculate. You just look at the population range. Big minus small is going to be 14. 60 minus 46. Big minus small is 14. So we compare the population range of 14 to the mean of the sample ranges. They're different. Okay? They are different. So which one is that? Not equal. Okay? Right there. Not equal. Do sample ranges target the value? Well, no, they're not the same. Okay? Do not target, therefore do not make good estimators. This one. Now 4, it's the same thing, but 4 has something that really confused me. I think proportion is a hard concept to understand. It's how many you're looking at, how many of the things are that you're looking at out of the total, and it's really confusing to me. I mean, it shouldn't be. It's easy, but it's not. When 2 births are randomly selected, the sample space is this. Assume that for those 4 outcomes are equally likely. Construct a table that describes the sampling distribution of the sample proportion of girls. So that's kind of it. We've done something similar where we talked about the number of girls, but this is not quite the same thing. So let's think about it this way. What could happen is you could have a boy and boy, boy, girl, girl, boy, girl, girl. So what is comfortable to me is to say the number of girls is 0, or these 2 together make 1, or this one makes 2. All right? So you can either get 0 girls or 1 girl or 2 girls, and I think that makes perfect sense. There's nothing hard about that. But this is talking about the proportion. Okay? Proportion is like part over total. So think about it as 0 out of 2, which is 0. That's the proportion for 0 number of girls. And this is 1 out of the total 2. 1/2 is going to be 0.5. And then you could have 2 out of 2 is 1. Okay? So notice those are not probabilities. You can tell it's not probabilities because it doesn't add up to 1. But the probability here, I think probability makes more sense. The probability of getting 0 girls is 1 out of 4. The probability of getting 1 girl is 2 out of 4. And the probability of 2 girls is 1 out of 4. I thought those numbers were just kind of tricky. So then they ask the same question, right? They talk about the mean of the sample proportions. Well, the mean of the sample is going to be 0 plus 0.5 plus 1 over 3. Which equals 0.5. 0.5. And the proportion of girls, okay, for the population, this is population. It doesn't say it in the problem, but it doesn't have to because, we're assuming that it's a 50-50 shot that you have a girl. Okay, so the proportion for having girls, we know that's 1/2 or 0.5. And so I think this problem is almost so simplistic. It's tough. Well, I guess maybe it says right here, but they're the same, and that's kind of the main idea. Not 1/3, not 1/4. Yes, both mean of sample proportions and population proportion are 1/2. Looks like it's choice C right here. Does the result suggest that a sample proportion is an unbiased estimator? Yes, because they're the same.